Okay, my friends, I got another shocker du jour. They have always said the galaxies and the whole universe is expanding because there's a red shift. And a red shift means that the light coming to us is shifting slower and slower. And that is really what it is doing. But they say no, light goes the same speed forever. Nothing can change the speed of light. That is totally incorrect. And I prove it right now to you. So what they say is the universe has to be expanding because the light is being stretched. So they're saying light is being stretched, being pulled away. So we're over here and we're seeing it shift to the red. Red means there's a longer wavelength of the frequency. That's just not true. I can speed up and slow down light. It's very, very simple. It happens all the time. And they just don't realize it because Einstein said this is a law. The speed of light is constant. No, not correct whatsoever. All right, here's this LIGO again. Remember I showed you they're looking for these gravity waves. And they say, why should we detect them? What's the source of these waves and all that stuff? Now, here's what they're looking for is these right here, these waves in space, these gravity waves. Well, we found them, and here they are right here. This is what it is. Now, gravity waves, to me, are nothing more than the field effect of things spinning in space. And when they spin, they have to react with all the other particles that are in front of them. So it charges up and discharges, charges and discharges, charges and as they spin and they charge up and then they discharge a little bit. They charge up and that's when it goes and then it slows down to charge and discharge, and that's the end of the field. But that field is related to something out there that is spinning in space. Because every single thing there is made of dipoles. If you see here black and white, black and white, black and white, everything is black and white. And why is it black and white? Everything is a dipole. There is nothing but dipoles. And when they spin, they create that fluttering effect of fields. They flutter, 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 and the field goes out, push and shove, push and shove, pushing. And originally it's going pushing real hard, shoving back hard, pushing hard, shoving back, and eventually it sort of wears itself out. And by the time it gets out here, it's all over. No more push and shove, and that's the end of that field. But any particle that has to travel through any of these fields, and the whole universe is saturated with it, is going to have to slow down. It's going to bounce into these fields. There's nothing you can do about it. And these are not homogeneous. They're different everywhere in the universe, as is witnessed by this. If you have to come through this thing here, bam, you hit in there. All of a sudden, you're slowing down. You might go fast out here, yes. You might go fast out here, yes. But what if you have to come through all this stuff? It's going to slow it down. We have no idea where we are in the universe because light does not go the same speed. And that I also show extremely clearly. Here's blue light. It's from a blue laser. It's coming through real fast and slowing down. As they slow down, the light particles separate away from each other. And when they're really powerful, they're just bap, 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 bap. And that's how it goes. It's and it keeps slowing down. Light slows down. They say no, light doesn't slow down. Yes, it does. And it also speeds up. And here it is right here. Well, here's the best way to show it right here. That's a normal light wave from a pulsed red laser. Light is light. I don't care where it comes from a light bulb, a laser, from a campfire. It doesn't make any difference. If it's brilliant and lit up, it means there's a frequency of light coming that is strong enough to make all the other fields in front of it glow. And that's what this is doing. These are all the fields glowing that are in front of it. You see? These little particles, those are all gases. Right, every gas is made up of the same thing everything else is made up, is dipole electrons. They're made up of these little tiny bar magnets in a ball. And when this magnet field comes through here, it has to push that field out of the way. So these are actually being illuminated because of the huge field effect that's around here. It's not just this right here. That's the wave, and the particle is way back in here. And the particle here is being accelerated. All right, so don't tell me you can't accelerate them and you can't slow them down. I just showed you both. Here's the acceleration, and then it exploded at the venturi. And that's fission, and that's fusion. It broke the black part away from the white part. And you say, what black and what white? There it is right here. This is the particle. You never see that because you just can't see it until you do what we did with the venturi to accelerate it. And then you can see the photons just start glowing. The green does the same thing as the red. And then they make the Higgs fields and all the same stuff that they're talking about at CERN. It's actually quite simple, to be perfect honest. And the thing they don't understand is they think light is flaps like this. That's not at all true. Light goes just like this. It spins. If you looked at it from the side, that looks like a wave, yeah. You could take that as a wave. But it's really a spinning particle. How can I prove it? Well, here it is right here. That's the particle spinning. Now, there's a bunch of these. They're all over the place here. When that light comes through, there's thousands of these. But this is a slit right here. And what happens, sometimes they go that way. Sometimes they come from the underside and go this way. That's why this looks just like a drill bit. It's actually literally screwing its way through the slit. And this is on a back wall. This is the light that comes out from the other side of the slit. So the slit is back here. And way down there, this is the pattern we see, because some go this way and they come and they sort of drift off this way, some drift off that way, but most of them come through the center. This proves that light spins, and it's not. And I also can prove it with the blue. You see it in the blue as well. Here's the blue, same thing. Light spins. And I can tell you, no question whatsoever, that's spinning, because this is coming in real fast and it's almost straight, and then it drifts off to the left because it's spinning to the right, which means it would drift to the left, the light particle. All right, so there is no question it is a spinning particle, and that particle is the same green as it is red. Same particle, that's a photon. And a photon is two Dirac neutrinos. And these people will understand this at Caltech. And you should by now, if you've been following my stuff. I've been doing this for 5, 6, 8 years now, actually. The dipole electron flood theory. And this came from 8 years ago. These pictures are from 8 years ago. And here's the light coming through here. As I said, there's a bazillion little particles coming. And then we ended up crushing all of these fields down into one little, boy, I'll tell you, that thing is dusty. One little tiny slit. And they all came down and squirted out the other side. And here's that event occurring right here. All right, here's the particles coming down. They're all over the place, these fields. They're coming down, and there's a venturi here. So they all have to gather together and squirt through that little venturi. And the black ones can't get through, only the white ones can. And I showed you the black and the white. And of course, this is green, but the green does exactly the same thing as the red and the blue. You can separate the black from the white when you put it through that venturi. And here is the exact situation occurring. The black stays here. The white just continues on and gets squirted through here because this is pulsing. And then the black reattaches instantaneously back to the white, because that's its mission in life, is to be glued together. They call them gluons. The black and the white glue on together. And then two gluons make a photon. All right, so what is a gluon? Well, here it is right here. Hold on, if I can find it. All right. The black and the white together, that's a gluon. Two of them back to back make a photon. And that is basically a stable particle because it has back to back. It doesn't want to give one of those up, and it doesn't want to take another one on. The only next stable particle from a photon is going to be a proton. And then a neutron right up in that area, they become stable again. And I can't tell you why. There's got to be something that shakes them until they hit that frequency, and bam, they lock in nice and solid and tight. It's not one big ball like this that you can shatter into all kinds of different pieces. It's one big ball like this, but every particle in it is a dipole. And that's what dipole electron flood theory is that everything there is made of these two particles. There's nothing that isn't. Life is made of that. Dirt, rocks, and air, and oxygen, and you know, everything. 100% of everything there is made of these two particles, and that comes from the sun as light. All right, and it interferes with, invades our atmosphere, and that creates that hell of a hot zone out there in the ionosphere. Ions mean these particles, ions, electrons, basically, ionized particles. They have extra charges. And they're scrubbing through every other extra charge, because I showed you what the galaxy looks like. Everybody's got to scrub against everybody else. All right, and when you get down real tight in the scrub, this is coming back. These arms are being bent back because the galaxy has to be moving basically this way or something like that, where the arms are twisting back. It's spinning at any rate, and it's spinning this direction. And the arms are twisting back because it's spinning. And it's getting more congealed of matter in the center. And that's what does form a black hole, because the black particles can separate from the white particles. Inside of there is a black hole. You think I'm kidding? I can prove it. Okay, remember what I said. Inside of that is going to be a black core, and all the white is collected on the outside, because they're all made of black and white. So why would all the white be on the outside? The black doesn't mind being on top of each other. See this? During the experiment, we contacted the Earth guys who couldn't believe it either. This was done in space, in a vacuum chamber with charged particles. The charged particles surround a black core. They make a black hole. Charged particles are the white parts, and they force the black parts in. This was back in 2015, or it might even been 2014. We were doing all this work that I showed you with these specific, all these pictures. These light pictures, this here, accelerating light, fission and fusion, raw electron showers, sterile muons, all done right here with just this. This is exactly what did this work right here. A Samsung Galaxy S3 phone from 2012, and this was just a Bosch construction laser, shined through two basically nails, and it forced the fields to come in together, and the white could squirt through, but the black just is one bowling ball. It can't get through. It's too big. And you can tune this to let some black through and mostly white. You can tune it so that there's only white gets through and no black. And that's what this is right here. It's 100% white coming through here. You know, this goes back a ways. It's coming back to me. I worked with the Russians about their sinkholes years ago, back in 2013, somewhere around there, 2014, right in that area. All of a sudden, they started having all these sinkholes in Yamani Peninsula. And they reached out to a Japanese researcher who was supposedly understood the sinkholes, but he had seen my presentation. He gets a hold of me, the Japanese researcher, and says, I'm going to refer the Russians to you because I think you know what's going on up there in Yamani. And I said, well, that's fine. So I did talk to the Russians, and I told them, I said, there's nothing you can do. It's from pumping all this stuff out of the ground. The tundra is going to collapse. And they started popping up everywhere. So anyway, then I saw this, which was the Russians in space. So, and I looked into their research into this formation of a black hole. So I figured, well, you know, they contacted me, I'll contact them. So I sent out an email to the researchers here and to Fermilab, to Don Lincoln, who immediately basically attacked me for making these statements and showing my evidence. Which, you know, I haven't gotten along with Fermilab whatsoever. I've shown 100% evidence to back up everything I've said, and I've shown their particles. Here it is right here. These are the Fermilab particles. They say, we wish we could find these. Well, we're doing everything we can. And this goes way back to 2013. This article was by Don Lincoln himself. And I found him. I sent him all this. I said, Don, can we talk? No, you're a tinfoil hat guy. Don't ever contact me again. And that was Fermilab, and he's never backed off from that for the last 10, 12 years or whatever it's been. And here I am showing what we could possibly do to get free energy. And they're not into it to trying to help us. They're into it for trying to secure their job and their position, their status. He puts out videos almost as much as I do. And I don't think there's too many people put as many as I do. But he puts them out all the time, making all these claims. It's just totally wrong. And he refuses to discuss it with me. I found his particles. There they are. There's no question whatsoever. But we started with light. They started with huge particles like this. We started with this. So we could see every little detail. They started with this, and they get just big blobs of goo all over the place, and they say, well, we'll search for this for the next 5 or 10 years and see if we can find it. And yes, they did. They found the same particles that we found in about 5 minutes, using about, I don't know, $300 or $400 worth of equipment. And I know how much that must damage somebody's ego and their, you know, I'm sure they're really, I know they know about it, because all I'm seeing now is the same research that I've done, and they're putting it, everybody's got a slant on it with these gravitational waves and all there. Everybody's putting their dark photons, they're calling them now, and they realize the standard model's wrong. And I know they realize this is correct because it can't be disputed anymore. And that goes back from a paper I did 2019. But I've been posting papers on academia.edu since about 2015 on this dipole electron flood theory. And it works 100% for anything. I don't care what you can present me with. But I can tell you right now, we will never, ever, ever, ever be able to determine how far things are away based on the speed of light, because the speed of light changes. The speed of light is just like this. There's every one of the different frequencies is faster or slower, but as it hits things, they just spread out. They just say bang, boom, 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 boom. And instead of hitting real fast like this, they slow down. And that's not from being pulled away, because I just showed you light can accelerate right there and light can slow down. So they have to stop and take a look at these things, or they're just taking our money and spending it so that they can support their lifestyle, not to help us. And these are government agencies. I don't think this was right at all what Fermilab did to me. I mean, it was really disgraceful, to be perfectly honest. And not only that, when the Russians found this black hole that they actually created in the vacuum chamber, they also found this happen. That's DNA, my friends, and those particles came back. This is the same from the same experimental time. These look just like the amino acids as they fold into the double helix, and they just created this all by themselves. All right, so where did life come from? Well, maybe there. Because this is nothing more than particles of light. And the sun and every luminous body sends out particles of light all over the place. Some of them are just the black parts, some of them are just the white parts, some of them are photons, some of them are bigger, some of them are chunks. But this looks like it starts forming into, it sure looks like DNA to me. Okay, like I said, I'm not here to ruin anybody's day, but I'm going to tell you something. This is just not going to work. It says, more importantly, gravitational waves interact very weakly with matter, unlike electromagnetic radiation, which can be absorbed, reflected, or bent by gravity itself. They travel through the universe virtually unimpeded, carrying information about their origin that is free of distortion. So they think they can look way back in the universe because they're molding these waves to take out the noise. Well, I don't care what they take out. As that particle is coming to us, it has to go through all of these fields that are in space. All of these fields. The particle coming from here is not going to be the same speed as the particle that came through here. If there's a way out past this and it's coming through this area, it's going to be slower than the one coming through this area. There's no question about it. It's zero. So I don't care what they do here on Earth. There is no way in the world that they're going to be able to change that. It's just impossible. And of course, the light does speed up, light slows down, and this is it can't be denied. And we worked with light, exclusively coherent laser, pulsed laser light. So of that there is no question. And here it is without being accelerated. Here it is accelerated. Here's the Higgs fields coming at us. These are Higgs fields. There's the particles themselves of photons. This is the light slowing up and down, and this is the craziest thing I've ever seen, is this little particle here, and I know why that happened, and I can explain it to them if they want, but this is two fields colliding, and one of them was a reverse field, which spins inside of itself, gathering energy into itself. The other ones spin and flip it out, and both of them collided, but going opposite directions. This field stripped that piece off. This took me years to figure that out. But I'm pretty much on this stuff, so I would like to be part of this discussion. They talk about collaborators, and we got all these people working all around the world to see this stuff, and that's fine. I'm good with that. I'd like to be part of it, that's all. You know, supported by National Science Foundation, operated by Caltech and MIT. Everybody's involved in this, and because this is a new field, something that they can start to investigate. They think they've got a lot of this science locked down. No, absolutely not. If light can accelerate and slow down, and I've seen it, shown you what it is, it's a particle, the periodic table changes, because instead of this being one big proton, it's 1,823 dipoles, and then this is 7,000 something, and they go up into the millions probably by the time you get way up at the end, but they're all nothing but these little particles. So when you break them apart in a proton collider, you can get balls of them like this, or you can get balls of them like that, or you can get one or two, or 6 or 10 or 100 or 1,000. They're just a big ball of a mess. We can't get anything other than this. We can't get any bigger than that. It never does. So we see these exactly as what they are. Now they see them separated, flying here, flying there, and they say, yeah, this is the smallest one, but we got all kinds of other ones too. There's the standard model, has neutrino here and tau there, and up and down, and quarks and bosons and axions, and they're particles zoo. It's not that way. It's the only two particles that exist. They make everything there is. So, you know, like I said, I'm not here to ruin anybody's day, but I'm going to tell you right now, light spins. It does not flap like this, and going through the dual slit, it doesn't do this. It comes out like this because it's being opposing each other magnetically. The white particles hate each other. Those fields always want to repel. The black couldn't care less. And this is the black here and the black coming back. So that's fission, that's fusion. Again, I'm pretty deep into this stuff. So I'd like to be part of it. And this is it right here. This is the new dipole electron flood theory. And that's all there is dipole electrons. That's all that exists. And in bigger balls, they become matter. They become molecules. All right, but almost all the mass is involved in the black particle. And that also is from Fermilab. They agree with that. And I interacted with them years and years ago, and I was called a tinfoil hat guy, even though with all this evidence. And don't ever talk to us again. And Don Lincoln has kept that stance since then. Which I say he's basically destroyed advancing of this field. Because, you know, I've been referred to, you should talk to Fermilab, you should talk to this one. And I went to the University of Geneva, and I did talk to the people there, and I know they related it to CERN. Because they were seeing this, and they were saying, wow, that's pretty interesting. And, you know, they didn't shut me down at all. They just didn't want to get too involved because it takes away from their gigantic money device. the money vacuum cleaner that they have. Nobody will talk to me because of that. This is too easy, and it disrupts too many people's lives, and I'm sorry about that, but science, if you want to advance in science, you better advance. You better not just say, well, I was told to say this, and that's all I'm going to say. And I'm going to tell you right now, that's exactly what they tell you at Yale. Listen to this. All right, this is kind of funny. This guy here, Shankar, Professor Shankar, he's given the quantum mechanics courses at Yale. You can go to all this stuff for free, you know. They just don't give you pieces of paper. You can virtually go everywhere. I went through Coursera, like I say, I went to Rice, I went to University of Geneva, I went to Johns Hopkins, and all kinds of places. And this was not through Coursera, but you can just come up on here. But this was the funniest thing. He's talking about the key experiments, wave-particle duality, and quantum mechanics, and there's a bunch of different, well, a ton of different courses, but I'm going to show you what. Listen.
I want you to think about this as a real...
Here, I'm going to show you this. This is him.
All right. So.
All right, here's what he says. He starts out by saying this is a really important day. All right, so here he goes.
Subject that's kind of hard to follow intuitively. And the good news is that nobody can follow it intuitively. Richard Feynman, one of the big figures in physics, used to say no one understands quantum mechanics. So in some sense the pressure is off for you guys, because I don't get it and you don't get it and Feynman doesn't get it. The point is, here's my goal. Right now I am the only one who doesn't understand quantum mechanics. In about 7 days, all of you will be unable to understand quantum mechanics. Then you can go back and spread your ignorance everywhere else. That's the only legacy a teacher can want. So, all right. So
at least he's honest.
Which we are doing.
All right. So, and he's going to go through this whole thing, and it makes no sense. He's correct. It makes no sense. So there's nobody can follow it. So you just tell the next guy, you just state what I said, and I'll give you an A. And if you can't remember what I told you, I'll fail you in life. This stuff does not work for me. It's got to be a forum. You got to be able to speak up and ask questions. And I guarantee you, if I was in that class asking my questions, I would end up getting failed, because that's what they tried to do that to me when I first started this. And I fought so hard against it. I said, I'll tell you what, my friend, I will go against you. And I did. And we had to calculate the dipole molecular moment of some polar molecule. And the professor finally says, I give up. I'll give you the A. Yeah, he was going to, I wanted an A. I said, I know more than you know about it. Oh, I said, yeah, well, let's do it. I'll tell you what, let's do it. And he finally gave up. He says, don't forget about it. Just, I'll give you the A. You see this? These are the muon neutrinos, the black balls. They turn into a sterile muon. The electron neutrinos, which was the white ball that was attached to the black ball, turns into a shower, electron showers. They will know what electron showers are capable. Trillions of electron volts. Because this white, this is juice. This is the white juice that you put in your battery. In order to get that white particle, you got to strip it and pull it off of the black, and it is hard as hell to do that because they are tight. Well, it's just squirting through there all by itself. We didn't have to do anything because the way this is tuned, it kept the black from going through. It's too big. It's a fixed particle. It's too big of a particle. But they come right back together on the other side. They must be just laying out here waiting for it, because here you have nothing but the white juice, and that is what you put in your batteries. If you can just get this, it's trillions of electron volts versus before when it was together, it was only, let's say, millions of electron volts. We're going from a trillion, from a million. That's unbelievable. The excess energy, and that's it right there, excess energy. There's no reason whatsoever that I can think of that we shouldn't be able to harvest this with some very, hold on, something like this, where that white stuff comes through. That's all it is white, and that's the only thing you put in your battery. Your battery weighs 10 pounds. All right, you go out and drive 100 miles, and you're all done with the battery. There's no more juice left in it, and you die and you stop on the road. Your battery still weighs 10 pounds. You go back and you fill it up with juice, and you force the juice into it, and now it's got all kinds of energy. It still weighs 10 pounds. Actually, it weighs just the tiniest bit more. They say, it's inconsequential, that means nothing. No, it doesn't. It's all white, has no mass to it whatsoever, but boy, I'll tell you, it will go through circuits like any kind of a circuit to get back to that black. That is the energy. That's the energy right there. And we have squirted it, literally squirted it. And all we have to do is put a plate there to absorb it, but it's got to be the correct kind of, just like a solar panel, only a little more exotic, we can collect more. A solar panel collected too. But you want to get all the frequencies, because white light means you have every frequency on steroids. And the brighter it gets, the more luminosity you have, the more energy you have. The more energy you have, the more voltage you have. The more voltage you have, the more work you can do. It is not a big, hard thing to understand. And because we were working with light, they're working with huge particles. And they can't do this as we can. We should be able to do this and carry it around in a little handheld container and have all of these little lasers within it. And, just carry it around like this. Here, hold on. Something like that. All right, you have all your plugs in here, and inside you have about 100 lasers, 1,000 lasers, how many you want. Depends on how much energy you can get out of them. I don't know yet. There's got to be some engineering to do. But then when you get done, you could have 220 volts, 110 volts, 50 cycles, 60 cycles, AC, DC, USB, anything you want. Anything you want to come out of here. Once you take that white and you collect that white into your batteries, basically. And you don't even have to run it through batteries. You should be able to just run this and feed it right into your circuits without even having a battery. But it's, you can put batteries, obviously. And it's portable, and there's no way you can get hurt with this. You're only working with light, and it's only set, if you put your eyeball right in the middle of that white, yeah, you're going to be hurt. But if you didn't put your eyeball down there, you're all right. By the time it hits the venturi, by the time it hits the collector, it's all over. There's no, you can't get hurt with this. And the reason you get hurt with the big colliders is because when they squirt off chunks like that. That hits you at these speeds, you're in trouble. And they can be this big or they can be that big. They're still, that's your gamma radiation, your the big tough stuff. And but we're never going to get there. We started with this, so we can't get to there. We're never going to get to there. So we're not throwing hand grenades. And even these will collect so quickly back to the white, and the white will collect so quickly back to the black. It's never going to go very far. So there's no danger of this. I don't think. We could say there's all kinds of devices that you can do to pick up radiation. If there's radiation, there's radiation. It's like I have one of them radiation detector there. It's not a big thing to test this out, to figure it out. If it works, it works. If it works, we're in good shape. And we can have these things up and running in a couple of weeks. All of this stuff is developed, it's ready to go. All these regulation circuits are working, no problem whatsoever. You're sucking up electricity off of panels like this. They're called solar panels. This is exactly the same thing, only we're creating the solar electricity into, solar particles. And we're separating them. When that solar stuff hits your solar panel, it's got every now and then you'll catch a little electron here and one one over here and one over here that'll be cascaded downward into your collector, but not like this. Every one of these is coming down. Every single one of them is going into your collector. So I don't think, this is should be very, very, very efficient and solid state and cheap as hell. But I got some bad news for these people. If they think they're going to be able to see farther back in the past because they can squish these little waves, there's no way. Light is nothing more than a wave itself. It's a particle in a wave. There's a particle. If I put something here, it's going to hit it and slow it down. It's just going to get slower and slower. And when they come up with the cosmic microwave background radiation, that's just nothing more than light. It's gotten so slow that it's just barely even moving now. It's just like floating around out there. That's what the background radiation is, because its background is just already died out. It has no more speed left to it. It's hit too many things. Like I say, I'm not here to ruin anybody's day, but this is all another thing that's complete nonsense. Cosmic microwave background is the cooled remnant of the first light that could ever travel freely throughout the universe. Where do they come up with this stuff? The fossil radiation, the furthest that any telescope can see, was released soon after the Big Bang. Scientists consider it an echo or shock wave of the Big Bang. It's just light that's slowed down. It keeps getting slower and slower and slower. And then eventually it's just sort of floating around out there, and it becomes very cool because it's not banging. Anytime you bang a wave into another wave, you create heat. These aren't banging anymore, so they're cool. Okay, my friends, I'm just going to leave it with this, but as I showed you before, the universe is completely saturated with these fields that slow light down. Now, they're talking about why should we detect these? What's the big deal? It says these gravitational waves allowing us to detect and observe the universe in a way never before possible, providing astronomers and other scientists with their first glimpses of an unseeable wonders. LIGO has removed the veil of mystery on the universe, and in so doing has ushered in exciting new research in physics, astronomy, and astrophysics. Well, I would like to be part of this. They talk about collaborations and collaborators and working with people all over the world. I have something, I think, to show. And I've shown these basically what they're looking for, and I would like to be part of this. Because I do a lot of research in a lot of different areas, and some of it seems to be a little too much for most of these people to accept, so they've pushed me out of the research field altogether, even though I have all the evidence to support the things I'm saying. So I'm hoping that this will be different with Caltech. We'll find out. So far I've been disappointed, but who knows. And again, this is light accelerating. This is fission. Black is separated from the white here, no question whatsoever. And this is fusion. They come back together, no question whatsoever there. You don't have to have huge protons and smashing to get fission and fusion. You can use light. And this was what they claim is the cat's meow as far as being able to get electricity for free. Electron showers are absolutely stunningly energetic. Stunningly energetic. But they can't get them doing what they're doing, slamming big things together. They see some showers and they pick up some energy for a billionth of a second, that's it. We can squirt this all day long, never stop. And again, these are solid state devices. I don't think there's any reason that they shouldn't just keep running and running and running and just pushing juice out like crazy. So again, thank you for your time, and stay in touch with my research, because I'm going to keep poking the bear until they start growling back, because it's time to do that. I mean, what I have shown you is hard to deny by anybody that's actually, truly, honestly trying to find resolution for these problems and trying to find a solution to the problems we're in on the Earth. It's not I know that they have jobs to do and they have money to make and everything else, and that's fine. There's going to be a lot of research to do in this area now. I should open it up in a huge thing. They shouldn't have to make up all this stuff and waste all this money doing stuff they don't need to do when they could be doing research that uses that money to really benefit us, not them. And right now, that's all I've seen is self-interest in science. And like Max Planck said, it does not advance. Science does not advance. It advances one funeral at a time. Like one guy gets in control, that's it until he dies, and then somebody else will hopefully come in and change things a little bit, but boy, it's hard to do. So that's the end of it for today. LIGO, my good friends at Caltech, let's talk. That's all I can say for scientists. Okay, my friends, I'm going to leave it at this. Don't forget, we did all the things I just showed you with this right here. That's it. That's what we use. Accelerated light through a small venturi and picked up the signals using CMOS from a 12, 11-year-old phone. This was all done way back then. We had this stuff done long ago. So, like I say, I'm not here to break anybody's, to hurt anybody's career or anything. I'm here to just present what is factual evidence. And in order to advance science, you have to examine and start to talk about the factual evidence. I can make any kind of stories I want, and that's what's always happened in science, and that's what's happening today. They don't really have the truth. They have stories that got concocted to make them look like they're really doing some serious research. And here black hole, DNA forming in space, light particles, acceleration of light spinning, muons, electron neutrinos. I mean, fission, fusion. What else can I do for you, my friends? What else can I do? I love you all. Okay, my friends, again, not intended to be an insult to anybody, but truth is truth. Now, this is gravitational wave astronomy, and everybody's saying, oh, if you could ever do this, it'd be fabulous. And they're talking about from Galileo to everybody, and then Stephen Hawking. Here's observations in the microwave band led to the detection of faint imprints of the Big Bang, a discovery Stephen Hawking called the greatest discovery of the century, if not all time. Well, the Big Bang, first of all, is not real. And everything is not spreading out at a certain speed. And light is slowing down because it's being stretched. That's what they say. And that's why they say we can tell how far things are, how much the stretch is there. No, how slow it gets, the stretch gets longer and longer as it comes further and further, and eventually it just stops banging. It's just like that light field that I showed you. The stretch only lasts so long. You see, where was it? You see? And eventually it just stops banging and it becomes part of the microwave background. These things could be right down the street, basically. I'm telling you right now, they have no idea where we are in the universe. And, it's fine to look and think, but you have to look at all the evidence. Just because I'm not working in one of these factories that they have, that they do this research in, I'm doing research, but I think we're doing a much more intelligent way of researching this. So we're starting with the smallest particles that exist. They're starting with huge bombers like this. You're never going to get anywhere doing this. You have to be down as close as you can get to the particles that you want to find, which are the photons and electron neutrinos. And actually, that's where dark matter is too. That's part of the whole thing. Is dark matter is part of light. Light is half dark matter. You see these particles? Where are they? All right, this is light. Half of it is the dark matter. The only reason that light is moving is because the dark matter is with it. The dark matter is the carrier. The light is the glower, and it has no energy. So when you fill your battery up, that's all you're using is the light. And that's all we're squirting through our venturi. And I don't think there's any reason whatsoever we can't use that. So I'm going to leave it at that. I know I go over things a number of times, but I see people it bounces off them like it was just rolling them water off a duck's back. All right, I still love you all, and I will forever, my good friends. Time we see this brilliant radiance, which is energy, and use it. I think we can do it with a little handheld device. All right, once again, take care of yourselves, and let's try to get somewhere in science. Change the whole paradigm of science to be interested in reviewing and having a forum about evidentiary science, not just nonsense, somebody making statements, oh, this must have happened 60 billion years ago, or, I do material research, and I'm getting extremely frustrated because that is not even allowed in science anymore. It's not allowed. You come with evidence, stay away from us. That's all I've gotten. So again, I'm not here to ruin anybody's day, but I'm here to try to make all of our days better. All right? I'll talk to you later. Thank you. Bye.